Thank you very much. That's the first time I have someone reading my biography. That was very spooky, but thanks. Usually do those kind of things for important people, you know. That was, thank you for that. Okay. So anyway, so we're both from Italy. That's why we have weird names that no one can pronounce. But that's okay because when I speak in English, I even mispronounce my own name, so it's perfectly fine. So we're talking about playing with a satellite navigation system and playing with the traffic message channel. So what we have here is our gear that we made for, you know, showing you our research. We also have a big antenna here. So if you make stupid questions, we just sterilize you with this antenna. Okay, so be careful. Okay, so what are we going to talk about? So this is what happens when, you know, someone that is involved with security buys a car with a satellite navigation system, which is built in and has, you know, some cool capabilities about, you know, giving you traffic information. So I bought a new car last year. So, and of course, the first thing you do is not like driving your car and enjoying it. It's like thinking, that could be interesting. I could try to hack this system. So let's see if that works and if I'll be able to do a research and then, you know, get free tickets around the world for doing conferences. And actually, that worked pretty well. I mean, we've been presenting this work all around, and we're very glad to be here. This is the first time at Hacking the Box. And Daniele works with me with our company. He's doing hardware stuff. He's currently setting up the things for the demo. So what are we going to talk about? So modern in-car satellite navigation system, they have something called the traffic message channel, which is being used for giving you traffic information like queues, accidents, whatever. And you can use that information for enhancing your route home. And this is called the TMC, so Traffic Message Channel. And the full name of the protocol we're going to play with is RDS TMC. So why did we do this thing? So first of all, because it's fun, and owning a car is like priceless. It's very 80s because we're dealing with a technology which is, we're dealing with two technologies. One that is new, but it uses a very old transport protocol, which is very old and very 80s. So, you know, we wanted to play with that. And also because the problem is that people implicitly trust these kind of things. If you're driving a car, you would never expect that, you know, someone might tamper with your data, okay? It's far from being expected. And since there's a matter of trust here, we wanted to exploit that and see and raise awareness about the fact that this system needs to be more securely designed because of the future. And also chicks will melt when you show this. It's good for getting girls. And we'll prove our point with a video. Okay, so radio data system. So RDS is used for transmitting data over FM radio. Okay, so whenever you listen to a radio station and you see the name of the station on your radio, that's RDS working for you. Okay, so the way it works, what happens is that, so this is the FM spectrum. So here you got a mono signal. Here you got 19 kilohertz pilot tone. Here you have the stereo component. And right here at 57 kilohertz, you have a subcarrier that carries zeros and ones. So a data signal, which is digital, okay? So this is a way where we can use an existing, you know, normal analog radio and transmitting data. And RDS is used for lots of things. So as I was telling you, it's used for the name of the station. It's used for giving you alternate frequencies. So when you're driving and you're setting your stereo to a radio station and you're going to a different region, the frequency changes because in most countries, the frequency for a radio broadcaster is not the same across, you know, different regions. And so what happens, the radio gets an alternate frequency, and when it lost the primary one, then it falls back on the secondary one. You can also have the program time, so you can no one uses that, but you can say, I want to only listen to jazz music or whatever, and then the RDS tells you what kind of music you're listening to, and then you can put filters on it. It's not used at all, but the protocol you know, allows that. You can get news overrides. So you're listening to a CD, and you tell your radio station, if there's a traffic program which gives me useful information, please stop the CD and let me listen to the radio, okay? So if you have that functionality, that's carried by the RDS. There's one bit which is set to 1 instead of 0, and that means traffic program, and then, you know, you can use it. And so what they did for navigation system, they said, okay, we have RDS already. So why don't we use RDS for carrying traffic message information? So So this way, we don't have to build, new hardware, new infrastructure. We can just use existing, radio broadcaster for sending those kind of information. So what happens is that you have traffic messages, which are gathered by, I don't know, police, users reporting problems, or sometimes you have automated stations that they can detect if there's a queue or not. One of the very modern things they do, when you have mobile phone cells, if they detect a very, very high density of mobile phones in a specific area on a highway, then they assume there's a queue. That's one way for automatically giving you a warning about queues, okay? So what happens, they relay that information to a radio broadcasting station, okay? And then that information is being placed into an RDS stream, and then your navigation system is going to fetch the information and show to you warnings. And we're going to see what those warnings are, okay? So RDS is very old. It got introduced, lots and lots of years ago, but TMC is fairly new. It was invented in Germany, or else, in 1997. So Italy got it in 2004, and just to show you how relevant this is, Australia will get it only in 2007, okay? So it's a public specification, and even if it uses a very, very old protocol, it's still it's very, very modern, okay? So it's implemented in I would say 90% of satellite navigation systems which are built in your car. So if you buy a car in Europe with a satellite navigation system which is built in, you get TMC. And you can buy handheld devices, so handheld GPS devices. And if you get the very high-end model, you get TMC built in directly. Or you can also buy an external antenna that acts as an FM receiver, and then you can decode and see TMC. So RDS TMC is available in both as a free service, so you don't have to do anything. You just turn on your navigation system and it works. And most people, they're not even aware of that. They see traffic message coming in and see, oh, okay, that's cool. That's a cool functionality. And there are also some commercial services, and I'm going to talk about those. But the majority of services are free, except in the States, which is a very big commercial provider. TMC can also be transmitted over other mediums, so not only RDS, but also over digital radio. This research only focuses on RDS, but on digital radio it's going to be the same thing. The problem still exists. And the problem is that the data is in clear text, it's not authenticated, old news about computers, but, on cars, they have to rediscover things, all over again. And so that's what we're going to talk about. So this is a TMC terminal. So you can see we have patchy fog, the name of the road here. We have how far the event is from our position. So in this case, it was 215 kilometers. Okay, slow traffic. And what you can do, you can click on the event. And when you click on the event, you see the relevant map with an icon on it, and then whatever message you want. And this is like on demand. You have a list, you click on it, you see things. But when you are plotting a route and an event is affecting your current route, then you're going to either get a pop-up or different messages, okay? So you can either browse the current list of events, or navigation system is going to tell you, look, there's an accident, what do you want to do, okay? So the problem is that there's no form whatsoever of authentication of any data, and it's clear text, okay? So we thought, we could play with this and do whatever we want, and let's see how severe is the problem, and if we can do that easily without spending thousands and thousands of dollars. So one of our goals was building very cheap hardware to build a pirate station, a pirate radio station for sending those kind of signals, and see what happens if we send those signals to a navigation system. Okay, and so we use off-the-shelf components, and so this equipment doesn't cost more than $100. So it's very, very cheap. And we play on keyboards. We use keyboards all day. And we were able to do this. So if we can do this, believe me, anyone here can do that, even if you have no experience in electronics at all, okay? So this is the victim. So usually in IT security talks, you have the victim is like a computer, a server. This is a car. That was one of my motivation for the talk. I mean, isn't that cool? You can put on the slides, your victim is a car. I mean, that's kind of sweet for me. And so the first thing we needed to do was actually understanding what was going on. So we can see the messages on my navigation system. So we wanted to understand actually how the protocol is made, because we need that knowledge for actually playing with it, okay? So what we're going to do, we need to get a raw FM signal. So we don't need to get the audio components. So like left and right that you get on the speakers, right, in your car. We need to get the raw dump of data because we want to access the 57 kilohertz subcarrier, okay? So the way we do that, so we can use, there are modules for most onboard PCI cards for PC that can give you audio, FM radio, and also television. So if you buy one of those cards, which costs like $40 or $30 on eBay or something, there's a tuner on it, and there's a pin on the board. So this is here, this is a PCI. This is just a standard PC, and this is a PCI board, which is used for television. And the tuner here also gets FM radio. And there's a pin on it which you can hijack for getting your raw FM signal, which is MPX, okay? So that's the first part. We extract the raw FM component, okay, with that module. And in that website, you can get a list of modules that support this kind of functionality, okay? So once we have the signal, what we need to do, we want to, completely trash the audio part, and we want to get our RDS signal and try to decode it, okay? So for that, we use a TDA733OB, which is, a standard demodulator. In every radio, FM radio, you have that chip. There are 2 chips around. 50% of all radios have that chip for demodulating RDS. And you can buy it. You can go to an electronic shop and ask for one of those, and it costs like, how much does it cost? $5? Yeah, it's like insanely cheap, okay? And also, so what we want to do, we want to get data from it. And we want to do that with a PC. Right? Because we want to be able to access our data and decode it and whatever. And so what we do is we use a PIC, a programmable integrated controller for converting the information that this chip is going to give us in serial, so that we can hook that to a serial port and then get all zeros and one and get our data from our FM stream. Okay. So once we have all these zeros and ones, what we do, we need to decode them. For decoding them, we wrote our own software, which is called RDSD, which is open source, is available. There's another project which is open source around, but it's kind of old and it's not getting updated. And it just focuses on basic RDS. It doesn't focus on TMC at all. So we decided to redo the whole thing. Okay? So this is the board. Since you cannot see it here, this is the board. And what you can do, you can hijack a pin here, and then you get the MPX signal. Okay? So it's very easy. You solder, you beat there, and you get the raw signal. And so, you want to talk now?
Okay, yeah. This is our sniffing setup. It's pretty simple. We got the MPX signal from the VHF tuner, and after we send our analog signal to our sniffer circuit. Okay, our sniffer is really simple, as you can see from the image. The main components of the circuits are the TDA7330. That's the RDS demodulator, as Andrea said before, and the PIC, the microcontroller, the PIC 16F84. We use we use that PIC for many reasons. First of all, it's very simple to program. Its assembly, it's quite simple, so it's very easy to program, and also it's very easy to build a programmer circuit for that.
Okay, so this was the assembly part.
Okay.
Okay, we took 2 days for doing it with a very, very advanced lab. This is my bed.
Yeah.
Here we're just warming the circuit. Okay, this is sniffing circuit.
Yeah,
that is very simple. It's also over here. You cannot see, but then if you want to jump here after the talk, we can show it to you all the gear. So if you want to build it on your own, everything is published, and you can do it. It's very, very simple. I mean, we did it, so anyone can do it.
It's straight.
Okay.
Okay, so the PIC is able to get to us an important information about the quality of the signal that we receive. So we are able to distinguish between a bad quality data stream from we are able to distinguish between a bad quality data stream and a good quality, and that's really important because we can understand immediately if there is a problem in the circuit, in the sniffing circuit, or if our, I don't know, if our tuner is not well centered to the frequency we want to sniff.
Yeah. So it's very important from debugging that we
Yeah.
can actually see if we're doing the right thing or not. Because you're playing with electronics, you get 0 and 1s, things mess up very easily. So, but this way you can actually see if what you're building is, actually correct. And here you got a link for the assembler code we use for the peak programmer. So, everything can be made from scratch. So this is the output. This is actually a very low quality output. So you can see we got some 1s, some 0s, and then we got, some bad quality data. This is an oscilloscope, and this wave here. So this is the pure RDS signals.
Yeah, this is the analog RDS signal.
So our goal is getting from here to here and potentially have lots of 0s and 1s so that we're happy. We can decode things, and then we can play with binary, which is much more cool than play with C code or whatever. We can see binary. It's awesome. So RDS protocol. So how does it work? The RDS protocol is very, very simple because it's made for being space efficient. There's not too much bandwidth on RDS. Okay, so we want to be space efficient. So what happens here? We have 4 blocks. So it's 104 bits. We have block 1, 2, 3, 4. The first block, so every block has 16 bits of data and a check word, which is like a checksum of 10 bits. Okay? The first block has what is called the PI code, which is program identification code, which is a number, which is related to your broadcaster. Every broadcaster has its unique number. Okay? And it's public. You can find it on the internet. Okay? Then you got a check word. So this PI code is 16 bits. And then we have block 2, which we have the group code, which is going to tell us what kind of packet this is going to be. So as I mentioned to do with RES, we can send alternate frequencies, we can send TMC, we can send the name of the station, so lots of different things. So the type of message we're sending is decided by the group code. So depending on what this group code is, which is 4 bits, these 5 bits and the contents of block 3 and block 4 will be, will change, will be dependent on that, on what we put here. So our application, our navigation system, or the radio station, the first thing it does, so it checks the PI code if it's relevant to the station we're listening to, then it checks the group code, and according to what packet it is, then it goes to the code, everything else. This is the version code. This is TP, the traffic program, so that's the one responsible for stopping your CD and falling back on your radio if you're setting that functionality on. The PTY code tells you what kind of program you're listening to. So if jazz music has a code here, blues music has a code here, whatever. And these are free 5 bits. And then, of course, we have the check code. And the other 2 blocks are completely free. Okay? So TMC uses that in this fashion. So block 1 is PI code and check word. That's always the case with every RDS group. Block 2, we still have the group code. We still have TP. We still have PTY. And then here we can see the things change. We have something T, F, TP. And then we have other things here in block 3, and then we have a location code in block 4. So what are all these for? So the T, F, and D are used for something called multi-group message. So with TMC, we can either send a message within 4 blocks, or if you want to send more information, we can use more than just 4 blocks. We can send different groups, and that's a multi-group message, okay? Think about TCP/AP, you do packet segmentation, okay? So this is a similar thing. Then we have a duration and persistence of the event. So we get a queue. How long that queue is going to last? We get an accident. How long an accident is going to last? Okay, that's been specified in the duration and persistence bit, which is I think it's 3 bits. Okay. Then we have diversion advice. So if we have a warning about emergency telephones not working or rain, we are likely not to get a diversion advice from your satellite navigation system. Your satellite navigation system is not going to tell you, oh my God, the emergency telephones are not working. Please take a different road. That's not going to happen, of course. But if you get a serious accident or a fire or a road is closed or you get severe queue, then what they do is they put 1 in the diversion advice speed, and then your navigation system is going to pop up. Warning, look, there's a queue. Would you like to detour? Or would you like to return to your current route? Okay, so that's what's going to happen. Then we got the direction bit. So you have a highway, okay, and you want to know if the event is affecting this direction or the other direction, okay? And that's set in this speed, so it can be positive or negative, okay? Then we event the event extension. So I have a queue. How far does this queue go? Could it be 1 mile? Could it be 2 miles? Could it be 3 miles? Okay. Or if you have an accident, which is brand new, it will only be local. Okay. Or you have like snow, because TMC is also used for giving you weather information. Okay. So if you have heavy snow, how far is the area which is being covered there? Okay. So that's here. And then we got the event code. So the event code is the actual a number which is associated to a table of events, where you can see, number 123 is a queue, number 652 is an accident, or whatever. And this is a subset of the traffic management data dictionary, okay? And it's something that is stored on your navigation system, okay? So because we want to be space efficient, we just send a code, and then your navigation system looks up that code so that you can, translate that number to something that is useful for you, okay? And also, very important thing, we have finally the location, which is a 16-bit number. So what happens here? With TMC events, you don't get GPS coordinates in the message because there's no bandwidth for that. So you just get a location code, which can be only a 16-bit number. Okay, so we can have 6,545 locations, and so what happens is that in every country there's a different location table, which is stored on your navigation system. Okay, and so the navigation system resolves the number in the message to the GPS coordinates. Okay, so the problem here is that you cannot have a TMC message wherever we want. You can only get it in locations that are supported by the geolocation table and then actually encoded. Okay, so what they do, you have highways, you have major roads. In some cities, you have major arteries in your city, or you have ports or whatever. But you cannot place an event wherever you want. So that's a limitation of the protocol. Okay, but rightly so. So they found out since we have not much bandwidth. I mean, we do not care about putting a queue in the middle of a farm or whatever, or in the middle of the sea. We just code whatever major roads we have. Okay. And the location table, which is encoded in a specific format, in a specific standard, sometimes it is public. So, for instance, the Italian location table, you can just download it from the internet. Our government is so kind, and you can just have it, which helped us greatly. Or what you can do, you can also rip it from the navigation system. So if you have a built-in navigation system with a DVD on it, so you can take the DVD, you can put it on your computer, you can use strings on it, you can, sometimes they're encoded, but they're not really encrypted, so you can get the location table if you want, okay? So, as I was mentioning to you, we wrote a tool which is called Simple RDS Decoder for decoding messages. So what it does is so it's open source, you can download it here, and it tries to do full RDS TMC decoding. And that was vital for us, for understanding if our circuits were actually working for the coding protocol, then change it, and then send whatever we want. Okay? So think about Wireshark, if just for RDS. Okay? And you also perform basic decoding of RDS. So you can see the station name, you can see alternate frequency stuff, which was also very important for understanding if our circuit was tuned properly. Because we tune to a specific radio station. We have our software decoding the name of the station, so if the name actually matches the station, makes sense, it means we're doing the right thing, okay? And then we mean that if we can go and decode TMC messages, we're going to see the real thing. Because if you think about it, we have all zeros and ones, we have like a 16-bit number, and this is carried over analog, right? So you can get static noise, you can get, lots of problems. And if a zeros get a 1, or a 1 gets a zeros, you're still having something that makes sense to you. It's just that it's wrong. And the only way for understanding that is by checking the checkword itself. But the checkword is not safe. It's not like using SHA 256. I mean, it could be wrong as well. So you shouldn't trust it. And one way is actually checking the name of the station. So the first thing you have to do is you have this long string of zeros and ones. So you have to understand where to log for getting the beginning of your RDS message. Okay. So as we saw earlier, the first block of every RDS group as PI code as the first information, okay? And the PI code stays the same for your broadcaster, okay? So what you can do, you can just, simply look for that string, because that is going to be the most recurring string in your data stream, okay? And for knowing it, you just, Google for it. And if you, don't know how to get it, you can just, you can use our tool with this flag, and it's going to show you the most recurrent string in your stream, which in this case was like 5218, and it so happens that 5218 is the PI code for one of the Italian broadcasters, and it was actually the one we were tuned on, okay? And 5, every Italian station begins with 5, okay? So if you go to States or other countries, you get a different number, okay? And then, so you can download the location table from the internet. So what you just need to do, you invoke the tool with a proper PI code, which you find out in, other ways, and then you specify the location table, and then you pass the raw file, which is just zeros and ones. And what you get are the decoded messages. So this is one message. This is tuning information, and we got here. So what we have here, we get the program name. So we see RT. So the name of the station here is RTL 102.5. So what happens is that in every group, you only get 2 letters because there's no bandwidth for more. So you get 2 letters, and 2, and 2, and 2, and 2, and you construct the name of the station, okay? So here we only have RT. So this binary here stands for RT, okay? And also the tool is so kind to give you all the collected letters that you had before. So it caches what you've seen earlier, and then it gives you, the full name of the station. So when you start the tool, you actually see the name being constructed. You see RT, RTL1, RTL102, and then .5. So you actually check what's going on, okay? And here you have the raw data. So you have the data, the checkpoint, and the hexadecimal of all the different 4 blocks, which is useful for actually matching all this information which is decoded. Then you can change it, you can replay it, and do bad things, okay? So this is what we got from the air, and this is actually the decoded message, okay? This is finally the TMC message. So the group type is 8A. So 8A is being used for TMC. You see there's a program identification here which stays the same. It's 52108 here, and it's 5218 here, okay? Same thing. Then what happens here, we have a decoded group, okay? So we have duration and persistence. So 0, they're not giving any explicit duration. So what happens is your satellite navigation system is going to keep that event for whatever it thinks it's default, okay? Diversion advice, there's no diversion advice here. The extent is free. Free what? Free, we don't know. The satellite navigation system decides, okay? Then we have the event, which is number 115, which means slow traffic. And then we have the location, which is 3084. Then our tool goes on the location table. It decodes the location. And this is a big road in Rome. Okay, so we get the name of the road, we get the road code, and we get the GPS coordinates. Okay, so what we see here is slow traffic in a big area of Rome, which makes perfect sense. Okay, because Italian traffic is crazy. But you have crazy traffic too, so probably friends in that. Also, one thing that you have here, you have a Google Map link. So you can actually click on it and go to the GPS coordinates and see if your event actually makes sense. Okay? So this is TMC working for you. Also, one important thing, for TMC, we have 2 kinds of messages. So in 8A, we got the actual events, and in 3A, we got the system information. So what happens, this is used for detecting the presence of TMC on a specific channel, because your satellite navigation system needs to know where TMC is being broadcasted. And for doing that, it checks for 3A messages, okay? Which gives you the location table number you're using, and gives you the scope of the message. It could be international scope, it could be national, it could be regional. The reason for it is international here is that in Italy we have borders with lots of countries, okay? So we have France, Germany, Austria, Slovenia. So it's not uncommon to get messages from other countries, okay? So usually what they do, they broadcast on an international scope. Or sometimes, the broadcasting station, they just set that to 1 because they don't know what, they're doing. So don't assume they're using this in a smart way, okay? It never happens. So like, as we see in this message, like the duration and persistence is zero. That's never used properly most of the time, okay? And this is a plot on Google Maps. So we use the Google Maps API for plotting all the events. You can see we got lots of events here, which is Rome. We got lots of events here, which is in Milan. We got lots of events on this road. So if you live in Italy, you actually know that this makes perfect sense, okay? If you were to see like events here and here and here and here, we knew that probably something was wrong, and then some zeros were getting ones and ones were getting zeros, and it wasn't making any sense. But by seeing this, it makes perfect sense, which is a way of validating, we're actually sniffing things properly, okay? So now that we know how TMC works and what TMC does, we wanted to not only to be able to get messages and decode messages, but you also wanted to be able to inject messages, okay? And use that for, showing that, raise awareness about the fact that there is a security problem about it, and we should do something about it. So, as I mentioned to you, we did this for fun, also because we wanted to show a real problem, and also because we think it's good for getting GERS, which is, a motivation for us. So what we have here, we have a very, very cheesy movie for actually proving our point, because we thought, we showed to you lots of, the technical details. Maybe, it's early in the morning, you wake up at 8:50 for seeing, the keynote presentation, so maybe you're bored, okay? And so after all these zeros and ones, so we want to warm you up and show you our very, very cheesy movie to prove our point. So do you want to see the cheesy movie? Okay, good, right on.
Okay, darling. Let's go home.
Okay, sweetheart.
I love my new toy.
I know. You love it more than me.
We have to the door.
There's no answer.
No. I trust in my nuts.
But I can see the house.
No. Shut up. Where the fuck are we?
Look how good is a navigator now, huh?
Who the hell are you? I'm the evil hacker, and with my portable device, I injected RDS TMC messages onto your navigator. So now you are in my power. You are useless. Yeah. My navigator. Yes.
Who are you?
I'm the evil hacker, and I have all this knowledge because I followed
Hacking the bot.
the best conference in the world.
Yes, you're the real man.
Can you feel my power?
Yes.
Love me.
So it works. So that was for proving our point, because lots of presentations are boring, and if we can show that you can get GERS with that, then everyone will fall for it, okay? Also, I have to redub it because we will use this for other conferences. I always say the best conference in the world. Okay, so that was for proving our point. This is a warning. Your experience may differ. So we do not guarantee that you can build a circuit and something like that happens, okay? Okay, so what we want to do. So we use a commercially available RDS encoder for the bots, but it's very reasonable to build your own, okay? So this is for sending things, no longer receiving. So what happens is that this encoder uses something called I2C, for communicating with the chipset, which is a very, very easy protocol to use, okay? And so we built our own custom application for talking to it, even if the manufacturer is giving you a console for it. We just use our own so that we can play with the timing and do whatever you want. And so what we do, we set all parameters, PI code, PTI, whatever we want, and then with the remaining data, we set what we want, and we see what happens, okay? And the checkpoint is automatically being computed by the chipset, okay? And you can download the code for that over here, okay? So it's a crude code, so what you have to do for sending messages, you edit the source code, you put hexadecimal in here, and then you can inject, so it's not very user-friendly, but whatever, you'll manage it. So what we do here, so first we set the name of the station, and then these are the custom groups, okay? So this is hexadecimal. Here we translate it, so this is 85, This is binary, and as you can see, this is the first four are the group. This is B0, TP, PTY, DF, DP, and so on. For instance, here we have the event, which is 108 here, which is queuing traffic. And here we have the location, which is 1391, which is whatever, depending on your location there, okay? So what you just need a calculator, so for converting hexadecimal to binary and so on, but then you'll do fine. As long as you understand how the protocol is working, okay, then you can craft whatever message you want. And you can test it against your navigation system, and you can see if the navigation system is going to pick it up or not, okay? So what happens here, for doing the real injection part, okay, so you want to talk about this?
So, with our custom discourse application, we are able to inject in the EEPROM memory of the RDS encoder our custom packets, our custom RDS TMC packets. The RDS encoder output is connected as MPX input in the FM transmitter. And finally, okay, the transmitting antenna. There is nothing to say in particular about the FM transmitter. It's a normal one. It's a normal FM transmitter. The only important thing is that you have to pay attention about the stability of the circuit, because since we are transmitting a data stream that's a subcarrier of a certain frequency, it's important that the FM transmitter must be absolutely stable. And to do that, we need to insert in our FM transmitter and PLL tuning, digital tuning circuit. We have used that integrated circuit, SAA 1057 from Philips. That's PLL integrated circuit from Philips.
Also, that way you can select whatever frequency you want, so you can change the frequency. It's just not that you're building a circuit which is locked on a specific frequency. You can just change it, and then you can do it. Okay? And the important thing, you don't want your zeros that are being sent to get ones or whatever. So that's why it needs to be very, very, very stable. Okay. So what we have here we have both the sniffing device and the sending device. Okay. So sniffing, if you remember, we were getting from a serial port from our circuit. Okay. And for sending, we use a parallel port. Okay. So here we have the sniffing circuit, and this is the FM transmitter with the encoder, and they're both connected to this computer. So we send and receive at the same time. Okay. So you can do it with one computer. But also, if you want to do it on the long term, you just don't need the sniffing part. So what you can also do, you can build a very, very tiny device, this big, with a small FM transmitter, okay, which only sends whatever you want, and you can actually program it either by talking on a parallel port, or if you're really, good with the hardware, you can just put pins on the board, so you can select the zeros on one, and then select whatever you want. Okay, so you can have your own portable injector or whatever. So this is the encoder, which you can buy, and this is our FM transmitter, okay? Which is big because, we don't know how to miniaturize circuits. That's something that companies do, but it could be very, very small, okay? So transmitting FM. So we can tune to arbitrary frequency, and also very important matter about distance coverage. So here we're just inputting like 1 watt.
Yeah, 1 watt.
So with 1 watt of energy, you put your antenna like 10 meters, you can cover 1 or 2 miles very easily, okay? It's only a matter of power. You can boost whatever power you want, and you can reach very, very long distances, okay? It's not unreasonable to do. AM radio people, they do that all the time, okay? So if you really want to hijack an FM radio station, you can do that easily. But also you have to think about something. You might not want to affect all cars at once. Okay, you might not want your attack to affect, a bunch of people. You just want to affect one car. So you can do 2 things. You can always, hide somewhere, where the car is going to pass by, and then you can do your attack. Or you can build a very, very small device, and you can hide it in the trunk of the car. And no one is going to, realize what's going on. And also you will save from, local authorities, because they won't be able to detect your attack, because it will be only local, just with 1 meter radius, which is good enough to affect that same car navigation system and FM radio, but not you. Okay. So this is the transmission test. As you can see, he was outside with antenna here. So the sterilizer antenna, resistance is future, so you cannot have kids anymore. I'm sorry about that. Well, I was inside the car, safely protected, because I needed to test how the navigation system was behaving. Okay, so sorry for that. So video clip time. So let us show you how what happens when we hijack an existing channel. So this is a video of us tuning on different frequencies. Then at some point we'll reach the frequencies we hijack, and then we move away from it. So you will hear some static and radio station going on, and then at some point you will reach the station which is being obscured. Okay. So we're getting close to our station, which is 102.5, and you cannot hear anything. And this is like a major broadcaster in Italy. Okay, it's a very, very big broadcasting station. And we were testing this on Sunday. Oh, no, actually it was Saturday, and a soccer match was on. So now, if you know anything about Italy, just don't obscure soccer matches to people. Okay, so we've been very, very brave by doing that on Sunday. So, okay, so when injecting, so we can send, our messages and whatever, but very important thing to do is having your satellite navigation system locking on your station, okay? Locking on whatever messages you're sending, okay? So there are two ways for doing it, okay? So this is a navigation system. You can see this is a TMC icon. It's red if you're not getting anything, and it's green if you're getting something, okay? So what happens here, so you can do two things. You can hijack an existing channel like we did. Okay, so you get stations that they're broadcasting TMC, and you can actually Google for that. So you are able to know which station are broadcasting TMC. Okay, so what happens is the satellite navigation system has two FM tuners. One is being used for covering the whole spectrum and scanning if those 3A packets are mentioned are being sent. Okay, so let's go here for 5 seconds. There's nothing. Here for 5 seconds. There's nothing. And so on, so on. Here, oh, I got a 3A. That's a TMC channel. Okay, let's save that information. Okay, let's go on. Let's go on. Let's go on. Oh, there's TMC here too. Let's go on. Let's go on. And then the other tuner locks for a longer time, like 20 or 30 seconds, on those frequencies that are, being scanned by the other tuner. Okay, I know there's TMC there, so I wait there 30 seconds and get all the messages, and then I move on to the others. Okay. So what you can do if you know there's a radio station which is broadcasting TMC, you hijack that frequency because your navigation system are likely to have that frequency already cached into the other tuner. Then you block your station, you send your things, and the station is going, and the satellite navigation is going to get this. Okay. So the advantage of this is that you don't have to bother sending 3A packets and faking an entire station. Okay, and that you can also hide normal messages from your navigation system. Okay. The disadvantage of that is that it's very, very pervasive, okay? Because the main broadcaster is not there anymore. It's you, okay? And so authorities might be able to find that out. Okay? So the other thing you can do is that you can fake a completely new station, because the problem here is that there's no authentication whatsoever. It's not that there's a list of trusted station, whatever. The navigation system is going to get whatever you're sending to it, okay? So what you can do, you can find an unused frequency where there's nothing on, okay, and then you send 3A groups continuously and plus your data message, okay, and your navigation system is going to lock on that, save you as a legit station, and then you're done, okay. This takes more time now, okay, so you need to follow your target, okay. Instead with hijacking, you can just sit on a tunnel, okay, where they're not getting other frequencies, and then you can send your messages. All the cars are passing by, and they get your message, okay, on an hijack station, okay. And since you're in a tunnel, you're only covering the tunnel, you're not broadcasting elsewhere, so it's kind of safe. Also keep in mind that the default time for every message, if no longer time is specified, is like 15 minutes. So if you're sending a message and then the car is going away, it's going to retain that message for at least 15 minutes. If you specify a very long time in your message, which you can do, since you're crafting the message, you could stay there for like, the entire day, okay? Which is longer than, which is likely to be a longer time, compared to the actual time the car is being tuned on, okay? So these are the two ways for doing. You can also be stealthy when hijacking an existing channel, because what you can do, instead of just obscuring the channel, since, as I mentioned to you, every radio station has a secondary frequency, what you can do, you can remix when injecting messages, you can remix with a separate receiver, you get the station audio component from the secondary frequency, and when you inject, you remix that into the channel. So if someone is being tuned on that station, and then you start doing your own things, it's not going to happen like in our video that the channel is completely obscure. They're going to get the proper audio for that channel. It's going to be weaker, granted, but they're not going to be able to tell a difference. So you send the audio component as it is, and then you're only injecting the RDS string. Is no one will be able to find it out. Okay. So the first attack. So standard traffic messages. We can create queues, bad weather, rain, smog, fog, fresh snow, thunderstorms. We can create full car parks, whatever. You're going with your kids to the theme park. Oh, let's go to the theme park. No, we cannot because the car park is full. Okay, so that could be useful if you have children. And we could have overcrowded service areas. We can have accidents, roadworks, and so on. They're not particularly exciting. We do not want you buy that we're able to inject these things, but just showing you trivial messages. Okay, but this is something we can do. So code 108, queue in traffic. This is message we put queue in traffic here. This is a highway, so people are likely to exit and then take a normal road or whatever. So that's an injector message. We can close roads. We can close arbitrary roads, bridges, and tunnels. Okay. So what happens if you're closing a road and your navigation is plugging a route to it? Your navigation system is going to pop up a message. Look, the road is closed. Okay. And so what happens in Europe that most people, they don't trust TMC, and not in Europe, in Germany, they pretty much everyone trusts TMC. I would say in Italy, they don't trust, messages about queues, because they know there can be a small delay between the event itself, which is being, sent to your navigation system, and the real queue. So you see a queue, and, you think, okay, maybe the queue is already gone, so I'm keeping on my route. But if you close roads, which is like, something very definite, the road is closed, then people are going to believe that. Okay? And so they're going to detour. But even if they're not going to do that, what happens here, so in the navigation system, you have a setting which says, warn me if there's a detour, I want to make the choice. Or you can say to the navigator, you make the decision. If by TMC you're getting a detour, then you automatically apply it. Okay? So some people, they use it in that fashion. But what happens here, even if you're not specifying automatically detour, if the satellite navigation is recalculating the route, which happens all the time. You get into a tunnel, you lose the GPS signal, your satellite navigation system recalculates the route, okay? Or you take a bad turn, recalculation. So what happens if there's a closed road on your route, the navigation system is going to silently avoid the road without even telling you, okay? So if you're driving my place, I don't want you to reach my place, and you don't know anything about roads. I just close all the roads, okay? And I just leave only one open, and then your navigation system is going to tell you, go that way, without even telling you the reason for that, okay? And this attack is also known as keep your parents from reaching home, or keep your ex-girlfriend from reaching home, or your ex-boyfriend, whatever. I mean, you can use for that. So we have closed some roads here, okay? So this is a closed road. Road for going from his place to my place. And here you can see a pop-up, okay? Road is closed, what you want to do with a detour or return. So this is the interactive one. But what happens, this is a closed road affecting my route, you get a recalculation, and then magically the route is avoiding that closed road here. And this happened without any user interaction whatsoever, okay? So that's one thing you do. So also, attack number 3, there are some security messages in the standard which are not really used by anyone, but there are planned, there are in the standard, and you can send them. So without anyone ever used them so far, and the interesting thing about them is like, they might freak out, like Homeland Security, whatever. I mean, you're driving with your car, you're like, you have an escort or whatever, like escorting the president, okay? And it's your satellite navigation system showing you terrorist incidents, okay? Code 1518, terrorist incident, okay, on your navigation system, okay? So that could probably scare some people or could be annoy some people, okay? Also, one other thing you can have is air raid danger, So they have a code for advertising you air raids, okay? And they're so polite that there's also a code for air raid danger, air raid finished. So you can get a message, okay, the air raid, started, and then it's finished. Okay, you can safely go back on your highway. There are no bombs anymore. So, that's also, could be a problem. So this is an air raid near my city on our coast road. Okay. So also one nice thing about this thing. So, I do other things, in security. I don't play with hardware mainly. I do, lots of software things, And sometimes I go to my dad and he tells me, I found this very cool vulnerability in the Linux kernel. I can hijack whatever. And then he says, get a life. What's your job? I don't understand. And then I go to him and I show him, look, I can do this with your navigation system. And then he goes, oh, cool, you have a cool job, okay? So that's way more effective than that. So I'm only doing this kind of presentation from now on. And also, you can get an air crash, okay? So this is an airport, air crash. Airport, air crash. Airport, air crash. So that's pretty believable to me, okay? Code 978. Also, you can get bomb alerts, which is kind of scary, okay? And, this is actually a pop-up from security alert. Not every security message gives you a pop-up. Some of them do, some don't. It highly depends on the satellite navigation system you are talking. It's an implementation issue, okay? We only tested 2 of them, right? But, if you test 10 or 20 of them, you're going to see different results, okay? So let me show you a video. So navigation system, I want to go home. I set that as destination. Toll roads, okay. Wait 5 seconds, we're injecting. Oh, security alert, stationary traffic. This is the hacker over there with antenna. Okay, what I want to do? Okay, I don't trust this thing. Let's return. Okay, let me see the event list. What's going on here? Bomb alert, security alert, another bomb alert, air raid, closed road. So you can basically put World War III on the highway, okay? It could be kind of scary, don't you think so? And also, one thing you can do, okay, these are the security ones. You can get a bullfight on the highway. So I have my, I don't know about this. I have a theory about that. I imagine this is mainly a European standard. So I imagine like European community having a meeting, those important meetings, everyone representative for every country. And they're like deciding, okay, what message we should put there, And the Spanish people go, we get those, please. Can you have bullfight for us? Because they actually get those in the city. So, that's how I like to think that it works that way, okay? You can get delays due to parade. You can also place a boxing match on a highway. You can get boxing match. But if you think about it, in Italy, after an accident, having a boxing match is not so unlikely. So that could actually make sense. You can also have other sport things. I don't know, whatever you want. So, these are funny ones, but still, they're so, and, apart from that, there are some implementation issues. So people, manufacturers, they believe they're using the protocol correctly, but, actually they're not. So the PI is not associated to the frequency at all. So when we first tried doing these things, we were careful. Let's set the PI code, which is the program identification code, accordingly to the frequency we're trying to hijack. But the satellite navigation system completely ignores that. If you put 6666 as a PI code, it still works, even if you are, whatever. There's an event which is for total cancellation of all messages. It doesn't work. It's not being honored. But what you can still do, you can delete every single message. So if there's an event for cancellation, if I put a cancellation event on a specific location code, then if there was an event on that location code, then it gets canceled, okay? So you can sniff all the events, you can see, oh, they're sending all of this and this and this, and you can send cancellation for all of it. So what you can do at the Lion service. You can prevent anyone from getting TMC messages, okay? The standard allows a broadcast message. So what we wanted to do, we wanted to send a broadcast message, which supposedly should be able to work either if you're not flooding a route, it doesn't work, it's not being honored at all, okay? The version bit is ignored for most of the time. You set the version bit to 0. You put a Q message, the navigation system is going to ask you for the version, even if it's 0, okay? You have a boxing match, you put the version bit to 1, it doesn't work that way. It doesn't show you a pop-up. Oh, look, there's a boxing match. Maybe you want to avoid it. It doesn't work like that. But this is only the navigation system we tested, okay? So they're violating the standard. So we're pretty sure that other navigation systems, they have, similar or even more interesting issues. We don't know. We didn't spend time and money to buy 15 different navigation systems and test this, okay? But we expect that there are some other problems. So, as I mentioned to you at first, there's a free service and a commercial service, okay? The commercial service uses lightweight encryption, okay? Encryption is not really encryption at all. So what they did is that they had this problem. So every TMC message is free on the air. You turn on your car and you get those messages. So vendors asked the forum from the standard, people, we want to sell that service, okay? So can we please sell it? So what they did, they put encryption on it, which is like bitwise operations, which what they do, they obfuscate the location code only. So you need to have a specific custom table for reading them, okay? And by what you can do, this is not relevant at all to our research because we can still inject. Because all navigation systems, they're still, getting free messages. So if you want to inject, you can do whatever you want. And since they're only bitwise operation, you can just stay there for 2 hours, get the messages. You can compare with the decoded message on your navigation system. You get the key and you do whatever you want. So it's not really interesting, okay? So the problem is, it can be trivially injected. Drivers don't tend to have any security awareness towards satellite navigation system, okay? If you're using a computer, now even my mom knows that there are viruses and stuff, so, might have a clue. With cars, no way. You would never expect something like this to happen, okay? So our point is that we don't want to attack TMC. We don't think it's bad and crappy and it's the end of the world. Oh my God, we have a problem, okay? There was a reason because they use RDS and whatever, okay? What we want to do is raise awareness for the future, okay? Because the next protocol, they're going to allow you to use your credit card on your car for downloaded services on demand, okay? What they're going to do in the future, you can have an emergency vehicle broadcasting to other vehicles. Look, I'm coming on the highway. Please move away. And that's what we do in a peer-to-peer fashion between cars. So it's very important that they start to getting these things right. And they shouldn't make the same mistakes we made 20 years ago with computers, with our services, our login, RSH, whatever, okay? And since we saw that now with this technology, we just wanted to say, look, it's not the end of the world because we don't accept people going around building those circuits and messing up the whole system, like that. But, still, for the future, just be aware. Also because you cannot patch a car easily. I mean, I have my car. I'm not going to change it because of that, okay? It's not like a software you can have, so they have a very long life, okay? So we got an official response for TMC forum saying hacking TMC unsuccessfully because they were very scared by our research because they didn't get our point. And they say very funny things, so I'm just quoting them, okay? The first and override this statement, so they say that this contravene each country's respective broadcasting legislation and laws. So thank you for saying that this is illegal. We don't really think that's a good defense about that. We never pretend this was legal, okay? It's not that, okay, murder is illegal. Okay, then we're safe. It doesn't work like that. So then they say there is a chance that false message could be decoded, but the degree of knowledge would have to be gained on parameters of the message being coded. Of course, we can get the entire knowledge we want because this is entirely clear text. So we know exactly what we're seeing. The random use of any location code will result in a randomly located event. We don't inject random things. We know perfectly what we're injecting. So all the response was completely pointless and not relevant at all. And the last sentence is very funny. Service providers and broadcasters, I am sure, have many protection mechanisms and processes in place. So, they trust the transport layer, which is like, bullshit. So you can read our full response here, their response here in our reply, okay? So the future, as I said, they're still using TMC over digital radio, no problem at all. The TPEG Transport Protocol Expert Group, which is thought to be the successor of TMC, it has the same issues, okay? The new thing we're looking forward to play with is GST, Global System of Telematics, which is the one, where you use a credit card and stuff. They're using PKI and all things, because they have credit cards. So the sad part is they don't really enroll encryption because they want security. It's just because they have credit card vendors, having standards. So, so we're going to see what will happen here, okay? In the States, there's Microsoft Direct Band, which uses a very similar system, but it's actually good because it has more bandwidth, so they're encrypted everything. It's actually pretty decent, Okay? But it's a closed standard, so it's not going to be available in Europe. Well, TMC is available worldwide because it's, you know, States, Europe, Australia, whatever. Maybe it will come here, I don't know. So this is kind of problem. Okay? So this is the end of our talk. We're running out of time. So thank you very much for listening. I hope you enjoyed our video. And if you have any questions,